Yeah, I'll go. So we are talking about migrations. So our ORM object relational mapper. So I just forgot to explain why it is called relational mapper. So we are using classes to create tables which are called relational. So object relation mapper. So that's how ORM name came into it. So we'll look into migrations right now. So you have created student creation. That's we created student table, then added a column called age, then we created a table called test, and finally we altered the marks column to float type. So you make these changes in your classes, like the models which we created using SQL Alchemy. After that, if you do migration run, all the tables will be created for you automatically. So you don't have to go into the MySQL or whatever database you're using and create those tables. So migration run does it for you. So even after you make a change, you can run migration run and the changes reflect in your database. So also migration, so basically it stores the versioning, like history of changes what you made. So also it facilitates you to roll back. So suppose you made like two changes, you push into production, so you want to roll back into previous version, you can do migration rollback to a specific version. Suppose and also other examples where you need to use like ORM facilitates is, suppose you are doing development. So when many times when you download a code, you need to set up your database. You use SQL dump kind of thing to set up your schema or manually create each and every table. What now it is very easy for you. You can run migration run, and automatically all the tables gets created for you. And other example is in your production, you are shifting from AWS into Google Cloud. So again, you need to create all the database for you. So again, if you have ORM in place, you can just run migration run and all the tables will be created for you. All the database schema will be created. So this is all about migration. Next, we'll look into like I'll highlight what is JWT, JSON Web Token. So it is basically used for authorization. Like consider you're doing basic authentication using email and password. After authentication, normally one way is to send cookies and other is token based authentication. So JWT is a token based authentication. We return a token. So and this token in the subsequent request after you do a basic auth, like after login, you attach this token into the header and send to the server. So in this server, we validate whether this token is valid. Is he is a authentic user, and is he have the all the required access to access the endpoint. So let's look how the JWT token looks like. So JWT token has three parts. First, it has header. So header is nothing but it says what version of JWT we won't manually deal with. So then it has payload. Payload is what data we can store into the JWT. Normally we use the user ID we store into the payload. So with subsequent requests, when you send the token into the server, we can extract the token, check its validity, then we obtain the user ID. So who is the user accessing our API? And signature. So signature is the cryptography. It ensures like no one is tampering with our token, like no one can make the token. So basically we use JWT package comes with all the crypto things, so we don't manually do it. Normally it comes with public and private key RSA keys. So and this is the format. First XXXX, that is a header dot payload dot signature. So this is the format of the token. Let's look an example of the payload, how it looks like. So this is my payload. Normally I send like this. Subject for mentor, we have this mentor ID. We pass it as a SUB, and name, the mentor's name, and role, mentor. So in the front end, you can read the payload without any library. So we don't have any confidential data in the payload. We have just ID, name, and his role. So which we want to display in our website. Suppose someone is tampering with the like mentor ID, he want to impersonate as some other user. The signature, what we saw before, the signature, it's a like it's a hash. We can see it uses a crypto algorithm SHA-265. So that hash he can't change. No one can tamper with the hash. So even though someone changes the ID, he can't change the hash. So once we validate on the server, we can know like whether the payload is tampered or not. So you can explore more about JWT in jwt.io. So this is all about I have for JWT. Then we'll move ahead and look about role-based access control. So role-based access control is like more frequent when you develop like simpler apps. Most of the apps like has roles in it. Like for example, our app right now has student, then mentor and admin. We have three definite fixed roles. So to enable like role-based access control, we need to make some changes into our database schema. So let's look into what changes are those. So I'm creating something called user. So user is like the common things like the student, mentor, or admin. I'm using the fields which are like personal details into a new entity called user. It has user ID, name, email, password. Email and password are the ones used for login. I create student with user ID as a foreign key, which maps to the user ID. Then I have the student details followed by student details. And then for the role, I have a table called role, which has role ID, description of the role, and role name. So name in our case would be mentor or student or admin. Then now we need to map which user has which role. So I have an association table called user role. It has two foreign keys. One is maps to role ID and other is user ID. So this is how we create many to many relationship. So it can be like role can be mentor and user can be Nikhil. Nikhil is a mentor. So we do mapping like that. So let's see a basic code, how we can do role-based access control. So when you focus on the create student at the end, imagine like assume that login required is already implemented. You can see like at the rate of RBAC and it has like we pass a list. The list right now has only one element, which is like mentor string. So RBAC is a decorator. Again, it is a three-level nested function like what we saw above. I want to focus on like token equal to get create user token. So we are like, suppose consider you are using a token based authentication, you are fetching the token. So the token has the user ID within it. So and you need to know what all roles the user has. So what I'm doing is I'll query the table which we created before, the user role table. So I from the token I can know the user ID. I need to fetch the role. So I need to like query the user role and the role table to know the name of the role. So you can see the query. I'm querying db.user role. I'm querying user role dot query. I'm doing a join with role where role.id equal to user role dot role ID. So I want the name actually. If you see the next line, I'm fetching role name and I'm doing filter with token.user.id. So what I'm doing is here is under the user role, I'm filtering using the user ID, and then I map it to the roles to get the role, what all roles the user have. Once I have what all the roles the user have, I cross check with the roles mentioned in the decorator. So we have mentioned like mentor is one who can access the endpoint create student. So we use simple for check, and if role equal to role needed, we return the function, we execute the function, else we raise 401 unauthorized error. So moving forward, so instead of like hitting the database each and every time when we want to validate if a user have access to the specific role, we could also, as seen before, we can also embed the roles into the token itself. So if you embed the roles into the token, you can get what all the roles the user has using like by using simple token dot roles, accessing the roles what the user have. So this way we can avoid like number of database calls we make. And right now we have roles table. If you in your application you need like dynamic roles you want to create, like mentor should have access to these all things, that can be student can access these all APIs. Instead of, you can add one more layer for granularity called permissions. So under the API, we like hard encode instead of roles. Like right now I hard encoded mentor. Instead of mentor, it will be like create student permission. So that is the permission needed to access the API. So if you create permissions, you can have a role permission mapper. Roles will have multiple permission and user will have multiple roles. So you can introduce a layer called permissions if you need more granularity. Then instead of hard, right now we saw like we are hard coding the mentor or what all the roles the API has access to. Instead of hard coding, what you can do is create a new table called resource. The resource can have resource ID and comma URI. So URI is a unique resource identifier. Suppose there is an example in above, get slash API slash v1 slash student. So the method is get plus the route total constitutes the resource. So we can have a resource table and put all the URI and create a resource ID. And we can like map roles and resource. So this user have like this particular user one has access to role slash student. So if you do this, you don't need to like hard encode this endpoint. Like previously we are hard encoding like this RBAC we're passing mentor, what all the roles this API has access to. So now if you create these two tables, we don't need to like hard encode anything in the decorator. We can fetch uh, what is the resource, what is the role it has access to by using these tables. Then we'll move on to the final topic for today, message queues. Sometimes you want to, I'll show you an example first. Suppose service one you have and you want to talk to service two. Suppose you want to sell bulk emails. So when you want to send bulk emails, the producer which raises the request for emails, it can do like 100 emails per minute. But your service to like it can't handle like 100 emails like per minute. So the service one we call it as a producer. Service two is a consumer which consumes what is produced by service one and do some operations over it. Right now we are producing email task. So service two get the email task and sends rolls out the email. So basically what we were trying to solve using queue is producer consumer problem. So producer produces much faster than the rate at which consumer can consume. So what's the solution is like we put a queue in between. Once the producer keeps filling the queue, like this is an email to be sent, this is the email to be sent, and consumer at its own pace, it picks up an email task and rolls out the email. So we use these queues for basically asynchronous background task that takes like more time to complete. And basically another advantage of using queue is like service one can be of any language. Like service one, let's say it's in Python. Service two can be in Java or anything. So this message queue, like for example, like examples for message queue is like RabbitMQ, Kafka. So these library provide facility like if message one, like service one sends an email task, it can be read in any other language like Java. If it's service one uses Python to put into the queue, it can be read by Java or Node.js or any other language. So message queue software helps us with that. And other thing is like message queues are like you can scale message queues. Suppose you have like millions of records coming in, you need to obviously scale it. So message queue supports with that. So RabbitMQ or Kafka, they do support it. Moving on, you can have like more than one consumer. Suppose you want to roll out again email, but with one consumer you can't tackle the load, so you can have two consumers. So message queue is supported. Like this is one of the behavior you can achieve. Other is publish and subscription. So you have like service, like if you see there is a red box over it, like there are service 2 and service 3 can be like different service. When a change is made in service 1, you want to publish to service 2 and as well as service 3. Like for example, take right now, when you're sending a mail, you want to log somewhere, you're sending a mail. That logging is the task of service 2. And you want to roll out mails. That is the task of service 3. So what you do is service 2 and service 3 will subscribe itself to the specific queue. So when service 1 rolls out something like new message, service 2 and service 3 automatically, because they are subscribed, they picks up the message and they execute it. So you can look at RabbitMQ. It is a better, like it's a simple and easy way to use RabbitMQ message queue. So with that, I conclude my talk. Thank you.
It was a nice presentation. Thank you. Let's check if there are any questions. Arkadaşlar sorusu olan varsa alabiliriz.
English, please.
There seems to be no questions.
Okay, thank you everyone. Yeah.
Okay, thank you for participating in DFS Turkey region. See you again at another event.
Yeah, see you. Thank you.
See you, thank you.